Hello, it's nice to be with you today. I am Blake Grisham, an associate professor in the Department of Natural Resources Management at Texas Tech University in Lubbock, Texas, and also the director of the Wallow River Field Station, located at the Texas Tech Center at Junction in Junction, Texas. Before I begin presenting the pilot study, I'd like to thank the numerous scientists, educators, stakeholders, and students who have helped build support for this project in the long term, as well as collect data for the pilot study presented herein. In 2019, Dr. Daniel Green, myself, Mr. Joe Segrist, and Mr. Jim Ray, along with the students in NRM 5309, Fish and Wildlife Population Modeling, published a study in the Wildlife Society Bulletin using your data. It was 19 years of landlord data and included over 75,000 records of purple martin nest data. The title of that presentation was Nest Survival Data Confirmed, Managed Housing is an Important Component to the Conservation of the Eastern Purple Martin. And what we found in that study is among the available housing options and styles available among numerous vendors, including but not limited to those found on the PMCA website, had equal nest survival probabilities. And within context of those findings, landlords can and should buy houses that not only fit their financial budgets, but also their aesthetic needs. But we had a follow-up question. Given the various options of housing styles available on the market, which, if any, had internal conditions that were most favorable for egg survival and chick survival. Basically, among the available suite of options available for landlords to buy, gourds, metal houses, aluminum houses, wood houses, all sorts of individual and other creatively engineered houses, which ones kept the eggs and the chicks and the parents safe from outside conditions? And in the long term, which, if any, would protect them given extreme events associated with climate change or just day-to-day weather? So the goal of this study, which is a pilot study, was to assess microclimate, which is a really fancy way of saying very fine spatial scale temperature and relative humidity. Think of a single point, like why your dog lays next to the fan in the summer, because the microclimate is cooler there. Within those conditions, the temperature and relative humidity, assess if 4 different styles of houses, if those temperature and relative humidity conditions differed among those, and compare them to outside conditions, and then assess if the conditions, temperature and relative humidity conditions inside the nest cavity influenced nest survival of eggs and chicks in positive or negative ways. We started this project in 2020 as a pilot study with the help of Ms. Ariana Rivera and Ms. Lainey Saygraves and the Wildlife Society at Texas Tech. This is the pilot data that I'm presenting today, and they were collected at Jim Ray's colony in the small town of Canyon, Texas, outside the large, quote-unquote, large city, Texas, large, so to speak, of Amarillo. And please note, Jim's colony has approximately 100 nesting pairs among what can be described as only 20,000 houses. Now that's not correct, but Jim has every style, make, and model of artificial houses known to man, and he has had a long-term banding and monitoring program at his colony under all approved permits, and he's collaborated with numerous scientists here. So this would be an excellent spot for the pilot study. In 2022, we expanded the project to the Wallow River Field Station, where the name of the colony is Talkington's Purple Warriors. More on that later. That's my favorite part. Also expanded to Scuba, Mississippi, collaborating with Dr. Scott Rush at Mississippi State University and Dr. Daniel Green with Weyerhaeuser. Expanded to Happy Valley Colony with Chirpy Nest and Mr. Tom Brake, his specially engineered purple martin houses. Mr. Joe Segrist and the wonderful staff at PMCA. And the goal in the long term is to expand this project across the entire distribution of the eastern purple martin. And when I say expand, what I mean was in each of the 4 housing types presented in the top photos above in the slide, we deployed what's called an ibutton data logger. We programmed the ibutton to record one temperature and relative humidity recording every 10 minutes starting in March and ending in late July to incorporate the entire nesting and possible re-nesting season. The 4 housing types include Chirpy Nest, artificial plastic gourds, multi-compartmental aluminum houses, multi-compartmental wood houses. Please note, the photo below is from Mr. Ray's colony, which shows 3 of the 4 housing types and how they are at similar heights, and each gourd and or house and compartment was chosen at random. We deployed 5 ibuttons in each housing type. So we have 20 samples from each year among the 4 housing types. And then we divided those data up into 2 time periods to evaluate various extremes. And please note, on the southern high plains, where we are on the edge of the central and mountain time zones, daylight hours in the summer are extremely long. So we divided the data between daytime hours, 6 a.m. to 10 p.m., and nighttime hours, because heat and or cold and associated relative humidity may have various impacts. For example, excessive heat may cause eggs to die, or chicks to jump from the gourds, or cause the parents to abandon the nest because of heat stress. Or conversely, cold conditions, which were more likely to be experienced at night, at least in Mr. Ray's colony, may have negative impacts to eggs, freeze and or cause the eggs to die, cause the chicks to go into hypothermia, and or cause negative impacts to parents based on insect availability as they try to forage to either, 1, have enough energy to make eggs and or feed chicks. From 2020 to 2021 at Mr. Ray's colony, we collected more than 547,000 measurements of temperature and relative humidity conditions among the 5 replicates of the Chirpy houses, plastic gourds, wood house, and aluminum houses. We collected more data in 2021 compared to 2020 as we refined our methods based on best scientific input from the collaborators to maximize project goals while minimizing logistical issues associated with such a rigorous study. The data for 2022 has been collected and I'm in process of compiling and analyzing. Please note, I am not able to present those data today because we have exceeded 2 million individual recordings across the study areas presented before for this year alone. These data are presented from 2020, 2021 in Mr. Ray's colony, and the general findings within all of these graphs that I'm presenting is in normal conditions, i.e. if the summer's breeding season for purple martins are within conditions that are within average or what's expected of 30-year climatic means, all housing types are equal compared to outside stations, with a few general caveats and trends that are merely anecdotal at this time. 1, the plastic gourds in Chirpy were best suited to accommodate variation in environmental conditions. Aluminum houses tended to be a bit warmer compared to external conditions, regardless of what those conditions may have been. And the wood houses created what we call a magnitude effect. So if it was cooler outside and more humid, it tended to be more cooler and more humid on the inside. Converse to that, if it is warmer and less humid outside, it was also more hot as well as drier on the inside. Same goes for relative humidity. Those findings are the same. Please note I'm reporting vapor pressure deficit, and that's just a very pointed-headed academic way of saying relative humidity. The findings were similar. Compared to external conditions, the 4 available housing styles were consistent as well as had the same trends as mentioned for plastic gourds and Chirpy nest, the aluminum houses, as well as the wood houses. More importantly, the ibuttons that we deployed that included nests with active eggs and chicks all had similar survival rates among the 4 housing types that we assessed. Basically, the summation of our findings is for this one colony for 2020 and 2021 located in Canyon, Texas, plastic gourds, Chirpy nest, wood houses, and aluminum houses all produced equal survival rates among the microclimate conditions inside those individual cavities. That's a good thing. That demonstrated and had preliminary support that landlords can continue to purchase and install and maintain and manage their artificial houses that not only meets their budgets, but also their aesthetic style. However, 2022 has been an exceptionally warm and dry year, if you have not been paying attention. And the data collected this year will help us tease apart the impact of extreme environmental conditions that led to egg failure and chicks jumping. Please note, we have not quantified these relationships yet, but we do have some interesting findings. And again, they're anecdotal and preliminary. First, data inside the gourds at Junction, Texas indicated internal temperatures inside an artificial plastic gourd exceeded 150 degrees Fahrenheit. That's really hot, by the way. In July 2022, on days when ambient low temperatures did not drop below 79 degrees Fahrenheit, high temperatures exceeded 108 degrees Fahrenheit, and relative humidity was less than 20%. However, this 1 day or 2 days is an example of an extreme weather event that is outside normal expectations, given 30-year climatic data. And we noted, in general, when temperatures failed to drop below 80 degrees at night and tended to go above 100 degrees during the day, and it's Texas, it's always arid in our parts. When it's dry, we tended to have more egg and or chick failures. So the preliminary findings from this study suggest that plastic gourds, Chirpy nest, are, 1, they accommodate variability in environmental conditions as well as produce eggs and chicks. Those tended to be a little bit better, at least internally, compared to the aluminum houses as well as the wood houses. But please note, these data are from one colony from 2 years in one climatic region, and those 2 years represented what we would consider normal, a normal summer. We will report more findings as we continue to collect data in 2022 and beyond. So some general findings. If you live in a location with all 4 seasons in a single day, might want to consider plastic gourds and or Chirpy nest. Aluminum houses may be best with without indirect sunlight or colder climates. Wood houses are maybe better if you have areas with kind of stable climates, like a maritime climate. And the material of your house for individual and or multi-compartmental, we haven't assessed that yet, but that's the next goal. And these data are preliminary. That said, if you would like to contribute or be a part of the upcoming funded study that will expand this project to the entire distribution of the eastern purple martin, feel free to contact myself and/or Lauren Spute. That said, the most important part of my job is creating new young scientists who are enthusiastic about purple martin conservation and the outdoors. And this photo is from the Outdoor Learning Center located at the Walnut River Field Station, where the young scientists with the Talkington Young Female or Young Women Leaders Institute got to name our new colony and help develop our strategies for long-term conservation of the species. If you would like more information on the OLC or how to get a K through 12 program involved, given the demographics associated with purple martins, please feel free to reach out to Mr. Brett Mosley or Miss Cheyenne Mack. Thank you.
All right. Thank you for that, Blake. A really important study that's going on, and PMCA is happy to be part of it. And you guys heard there that they're looking for people all across the range to expand this study, because obviously houses up in Alberta are going to be encountering much different climatic conditions than those that just reached 150 degrees inside the gourd in Texas. So absolutely wild numbers. Let me find Dr. Green and bring him back in here. I did see Jim Ray answer a question in chat. Oh, did we just lose Dr. Green?
I'm here.
Oh, I see you. I saw Jim Ray, who was mentioned there in the chat. One of the questions was, are you taking into account... Actually, this was from Lori Doss, a PMCA board member. Hey, Lori. Are you taking into account when vents are opened in the gourds midway through the season? And Jim responded, the pilot study's locations gourds don't have added ventilation. That is something that would be considered as the study expands. And it'd be interesting to see, you know, in instances of extreme heat like that, you know, maybe that helps the gourds not get to 150 degrees. So that's obviously something that's worth looking at. Question here, Daniel. Were natural gourds included in the study? Will they be if they weren't?
That's a really good question. And we haven't really talked about natural gourds, but the more that I think about this, it is something that we might want to consider. There's this dynamic of the relationship between humidity and temperature is fascinating. And I know, you know, Blake put the emphasis that this is very much a pilot study right now, but 150 degrees in the gourd is, I still can't even wrap my head around that. That's so hot. And right now in Mississippi, we seem to be getting temperatures maybe 5 to 8 degrees above ambient temperature in our gourd racks. And so I think that's really where humidity is buffering that temperature and increasing the conditions for martins. And so natural gourd racks are probably going to act a little bit, I'm speculating here, but a little bit more like a wood house than a plastic gourd. And so that may be a preferred area in some of these areas, or preferred housing type in some of these areas.
Yeah, I think that's actually kind of the similar temperature difference between ambient and internal temperatures that we see here, at least in previous measurements. You know, about 10-degree difference maybe between ambient and what's inside. But yeah, incredible data. And my first thought was this thing, were those things working right? And I asked Blake, and he said there were multiple sensors in different houses that were showing the same temperature difference, which is incredible. D. Kirk in chat, anyone working on heated, cooled housing gourds? I have an answer, but Dan or Jim even in chat, does anybody, do you guys have an answer for that?
I don't have an answer for heated or cooled.
Got it. Yeah. So there is some. Well, the PMCA is working with a group out of southern Texas on potentially some active cooling built into housing that would come on automatically when temperatures reach a certain level. So kind of the next step beyond just, gourd vents and that sort of thing. So more of that to come. We're working with a group on a prototype. So no promises of anything beyond that, but there are people in addition to us looking at that. Let's see here. Yeah, Barbara, this season has been brutal here in Central Texas with added ventilation and shading, even with added ventilation and shading on plastic gourds. Yeah, it's just been inescapable. Yeah, Texas has just been absolutely blasted over the last 2 years between the cold and the heat and the drought. What used to be an area with thriving purple martins has had 2 awful years in a row, and populations are suffering because of it. So scary for the future with climate change in mind. Okay. Lori in chat, what about nesting trays in different houses? Were they all the same? Could they influence the temperature of the houses? Jim, do you have okay, well, Jim actually is chiming in here in chat with a little bit more. He has styrofoam strapped to the roof, misting systems. Or no, wait, he's just discussing possibilities. Folks try styrofoam strapped to the roof. Misting systems have been used. He personally showers his houses every hour, and saved it. It saved his martins when everyone else had all young jumps. So definitely the addition of a misting system or showering your houses seems beneficial. Every hour when it's over 100 degrees. Thanks, Jim. All right. Well, thank you, Jim and Dan, for the tag team on there to help answer questions for Blake, who could not be here with us.